Aniruddha Wagire. Dr. Aniruddha Wagire, the resource person with the very first session of FDP, has joined. On behalf of organizing committee, I heartily welcome Dr. Aniruddha Wagire, sir. Wagire, sir, am I audible to you?
Yeah, it's audible, sir.
Yeah,
Quite
yeah.
well, sir.
Yeah. The title of his session is Industry 4.0 Leapfrogging Opportunity for India. I would just like to introduce our distinguished resource person, Dr. Aniruddha Anil Wagire, who has done his B Mechanical and ME Mechanical, and subsequently he completed his prestigious PhD in mechanical engineering, and especially his topic was dedicated to Industry 4.0. He is presently serving as a lecturer in automobile engineering at Government Polytechnic, Awasari. And may I just tell you about his academic achievements? He has total 14 plus years of experience, including teaching plus industry. And he has done his master's degree in machine design, rather mechanical engineering design. And he did his PhD from Malviya National Institute of Technology, that is MNIT Jaipur, Rajasthan. His doctoral study topic was development of framework for Indian manufacturing industry towards adoption of Industry 4.0. So such a distinguished personality, and especially his presence as a resource person is more relevant to us because his PhD topic itself was dedicated to Industry 4.0 aspects. So with this brief introduction, I would like to request Professor Wagire sir to begin his session. Thank you.
Thank you so much, sir. Thank you. Good afternoon, all my colleagues and my friends. Happy to be here on this platform. And thank you, Raju sir and his entire team for inviting me here for this FDP, which is very relevant topic, Industry 4.0. Thank you so much, sir. So may I share my screen, sir?
Yeah.
Yeah, thank you, sir. Because of bandwidth, I need to switch off my video. Please allow me, sir.
Yes, sir. Yes.
I hope the screen is visible. With the
yes, sir, visible.
Yeah. Okay. It is taking some time to reflect on my screen. Please be bear with me for a second. Now it's okay. Is it?
No, not yet visible. Now it is coming slowly.
Yeah, it's taking time. I don't know what is happening here. Now?
Nice, sir. Azun nahi ala. Not yet.
Just a minute. There is some problem with my screen there. Just a minute. I don't know what is happening here. I just stopped the screen. Once again, I'll share the screen.
Okay. देशट्टीवार. Wagire sir. Hello. Wagire sir, can you hear me? फोन करून सांगू का? व्हॉट्सॲपवर.
Hello, sir.
I request the participants to just wait for a while. Professor Wagire is having some issues in sharing his presentation. He would be successful in a short while from now. In the meanwhile, I once again welcome all the participants, and it is really very good that most of our participants are enthusiastic about joining the session. Still, I would say that we have reached, yes, 50, that is half century. We have attained the half century. Tomorrow in the morning or before morning, let me tell you, in the afternoon, Dr. Sarang Joshi, a very senior academician and a professor at Pune Institute of Computer Technology, that is prestigious PICT Pune. He is going to focus upon artificial intelligence and machine learning in and its relevance in Industry 4.0. A very senior academician, so it would be very relevant. Unmuted. On the final day, he would be covering the 360-degree view of Industry 4.0. So that is again a very important session. I'm waiting for our Dr. Wagire sir. Is trying to reinstate his presentation.
Okay, sir. Let me put it on the presentation mode. See, it might be visible now. Hope.
Yes, sir. Visible, sir.
Okay, just a minute. Okay, shall we start now?
Yeah, please start.
Yes, sir. Thank you. And first of all, my apologies for this technical problem. So once again, good afternoon all my friends and colleagues. Happy to be here. Policymakers, technology evangelists, practitioners, and large gatherings such as World Economic Forum have articulated in the last few years, especially last 6 years, that we are in the early stages of what is known as fourth industrial revolution, which is also synonymously referred to as Industry 4.0. Their individual and collective expectation is that in the next few decades, vast majority of us from every field living on the planet will experience highly disruptive, massive, and unprecedented changes. Many of the changes will affect our life in a better way, in a positive way. Some of these changes will lead to adverse experiences, as history would suggest us. But it will definitely touch very essence of human experience. Today, we are experiencing the profound changes around us. We are living in the world of machine. And these changes are happening very quickly. I mean to say it's a super exponentially. The technology is acting an enabler in this change. If you reflect back in the history, in the last 3 centuries, the society have had and experienced the several paradigm shifts in the industrialization, of course. The current phase in the industrialization is focusing on, which is heavily focusing on interconnectivity, higher level of automation, machine learning, and real-time analytics. And this commonly referred to as we are discussing the fourth industrial revolution or Industry 4.0. The purpose of next 60 or 90 minutes would be to throw light on 360-degree of view of Industry 4.0 or fourth industrial revolution. In my discussion, I'll also unfold the phases of industrialization and what has changed in the last few years or few decades also will be discussed in this lecture. And very important point is that how this current ongoing industrial revolution is different from earlier 3 industrial revolution that we'll also discuss. If the time permits, I will discuss some case studies too. But to begin my discussion, let me start with a quote from the book written by Yuval Harari, who is a historian, who is a professor, And he has articulated this sentence. He has said this: the people are usually afraid of change because they fear the unknown. But the single greatest constant of history is that everything changes. And he has well written this history and the brief history of tomorrow. What will happen? So that has written very well in this book. I recommend to go through this book if you are interested in the technological history changes and what would be the tomorrow. So if you see the change, Homo sapiens have evolved in the East Africa 2 lakhs before the year. Then cognitive revolution took place 70,000 years before the present. Then agriculture revolution also took place 12,000 years before the present. So in each and every revolution, we have experienced the change, and that change is the very profound change in our life that has changed the complete human experience. So we are now right here, and we moved from this hunter-gatherer society to the agrarian society. From agrarian society, we have moved to the agricultural society, then horticultural society. So we have experienced this and we have progressed through the time, and we are now in the machine age. So we are trying to build the intelligence, that artificial intelligence in the machines. So merely 500 years before the present, we have experienced this scientific revolution. Merely 2,200 years before the present, it's 2 centuries before the present, we have seen the industrial revolution that we are now talking about. It's a 4th industrial revolution. And now we are progressed in the era where the human has transcended the boundaries of planet Earth. We have also developed the nuclear weapons, and that currently creating the threats to the survival of humankind. That is the negative part of our discussion too. We may not know what will happen. Now currently we are here at this position and the change is happening very fastly. We may not know when we can create the first non-organic life form, or we may not know Homo sapiens may be replaced with some superhumans. So there is a change, and the change has happened with the time, and that leads to the next industrial revolution, and that change is happening continuously, and that is the only constant. So what actually the change is called as an industrial revolution? That is the discussion point for us. So before that, I skipped one slide, this one. So I purposefully kept this slide because as you know, as we are progressing the ocean of technology and artificial intelligence, we need to take care of this unintended consequences also. We have intended benefits out of it, but these are some unintended consequences. This picture better reflects that thing, because the machine lacks the human values, ethics, empathy, love, and passion, and affection too. So these are the things. So if the change, that is the major change, happened at these 3 segments, that is industry, transportation, and society, then we called it as a industrial revolution. Now in this 4th industrial revolution, we are experiencing the change in the way we work, the way we manufacture the product, the way we sell or buy the product, the way we travel, connect, communicate, and transport with the people, transport with these things. And we are also experiencing the changes at the society level. Social structure has changed. We've moved from this society to the nuclear family. The way we live, work, interact, the home is interacting with the people, those who are living in the home. So these changes are happening. These changes are called industrial revolution. Basically, usually this industrial revolution, when we say it's an industrial revolution, there are new ways of thinking and doing. And there are new technologies that are coming up, and that makes the changes to happen in all these 4 factors: industry, economy, transportation, and social structure. social structure. So like this, there are 4 industrial revolution observed, and that was first coined the term 4th industrial revolution by Professor Henning Kangerman, a German professor, and Wolfgang Wassler in the Hanover Messe Fair, that was in the 2011. Until that, there was no any concept like a 4th industrial revolution. So this gentleman has given this terminology, and this was basically for German manufacturing industry, for the betterment of their manufacturing industry. And the German government has set up a working group to prepare a recommendation for implementing the Industry 4 strategy for their manufacturing organization and boost the technology in the German manufacturing industry. Later on in 2016, Professor this Karl Schwab, who is the founder and executive chairman of World Economic Forum, articulated this terminology with some examples, and it is a well-written book. Likewise, these are the 2 basic books or literature that are available. You can go through this and reflect upon that. And there are few books which are published by Indian authors also. One is the Kranti Nation, which is written by Pranjal Sharma in 2018. And another one is, which is basically in Marathi language, that is written by the Dr. Bhushan Kelkar, Industry 4, Navya Yugachi Olak. So these are the recommended books. You can go through this. And let us go with the unfolding what are the different industrial revolution in the past that has happened. The first one is a result of invention of a steam engine and steam power. It was in the late 18th century, in 1784, steam engine. James Watt has developed and patented the steam engine, and the use of the steam engine moved from the textile industry to the locomotives to the other shipping ships. And we can say that the father of the first industrial revolution is James Watt. And the first industrial revolution was all about the textile, coal, and iron. And here in the first industrial revolution, we replaced the horsepower, that is the human labor, with the machine power. So that was the mechanization era, we can say. And this process began in the Britain in the 18th century, late 18th century, and spread from there to the other parts of the world. So this was the first, and the inventions made in this are helped this first industrial revolution to perform the mechanization, and we moved from the agrarian to the handicraft to the one which dominated with the industry and machine manufacturing. Then in second industrial revolution, the electricity was the prime energy factor, and which next gives us a mechanization to the next level, that is the electrification of the your equipments, machines, and that removed the most of the laborious work of the workforce, and further mechanization could be possible with the this kind of a electrification of the machines. Here another important principle came in the second industrial revolution, that is the mass production, where the Henry Ford developed the assembly line for the production of the Ford Model T car, and that leads to the division of labor principle, which removed the most of the technical part of our out of it, laborious part, and that we move to the next division of labor concepts. The major inventions in the second industrial revolutions that led this mechanization or electrification are the telephone, ice engine, then electricity, electrostatic motor, aeroplane, assembly line, that is the major part in the second industrial revolution, and the invention of the computer in the mid 20th century. So that is another trigger point for leading the third industrial revolution. Third industrial revolution was all about the microelectronics and this computer and information technology, which has further automated the production. And currently we are in the era of third industrial revolution, where we can see the use of microelectronics, PLCs, and we are automating the machines. And this gives us the ability to work remotely, connect globally, and we can have a market instantly. You have a smartphone with you. So these are the inventions that are taking place in the third industrial revolution, and these are the inventions or prime factors where these are the responsible for third industrial revolution. Other important part is the rise of internet, which led this industrialization to the next level. So these are the prime enablers for the third industrial revolution. And the fourth industrial revolution is all about amalgamation of technologies like cyber physical system, Internet of Things, Internet of Services, then blockchain, artificial intelligence, and all these are there, which are talking about the fourth industrial revolution. So if you see this chart carefully, each industrial revolution gives you something that is giving you the profound change, either at the economy front, either at the transportation firm or society firm. So that has changed the work-life balance, that has changed the way we interact with the persons, the way we interact with the machines, all have changed. And if you see this carefully, the rate of change or the acceleration of the change is very high as we progress with this industrial revolution. So this chart tells you about the first industrial revolution is the result of mechanization, then electrification and information technologies. And now we are in the third, which is led by the German, but there are some dispute about this, because like the fourth industrial revolution concept or industry 4, we are talking about the higher level of automation. We are talking about the remote control devices, augmented reality, virtual reality kind of software or applications. We are talking about the collaborative work with the machines. We are also talking about the artificial intelligence, that is building the artificial intelligence or machine learning algorithms to drive this next industry. So this is about the fourth industrial revolution, and these are some of the examples what I discussed here. But what exactly happening at in the fourth industrial revolution, and how the change is happening currently in the last let us say 5 or 10 years, that needs to be understood very correctly. Then and then only we can understand this fourth industrial revolution. So exactly what is happening here is that different technologies are coming together, that is the convergence is happening. Meaning of this is these physical technologies, digital technologies, or biological technologies are coming together, and these technologies are areas affecting the social and economic sectors, like as I discussed earlier on these 3 fronts. And it has coming up with the new products and services, as well as the new businesses and models. What I mean by these new product and services is that everybody is using these technologies, these platforms. So what these platforms are for making your life better and improve the efficiency, work efficiency. So here we all, I think in our meeting, there is nobody is here that he or she has not used these apps for booking the ride, that is the ride sharing, that is the shared mobility. We have booked our vacation, we have booked the lodging or these platforms, Airbnb, Yatra, or Make My Trip, or Yo-Yo. So these kind of services we are now observing here, and these services are just like a product, but they are offering service as a product. That is the change is now coming up in this fourth industrial revolution. So the next change is that there are new business models are coming up, like e-commerce websites are there. There are cloud computing or digital streaming or artificial intelligence inbuilt platforms are coming up. So Amazon is leading the one who is the big 5 companies in the America, in one of the big 5 companies, this Amazon is there. And we are having a new experience of purchasing the things, buying the things, selling the things. We can read the book on the Kindle, Amazon Kindle, listen to the music, listen or watch the video on these platforms. That may be a Prime Video, Disney, Hotstar, Netflix. There are so many platforms are available. You can listen the music and this on the Spotify, Wink, and other music listening platforms are there. So who is driving these new products and new business models? That is the point. So here is the answer. The driving element is the internet. So what internet magic is doing is this one. In 1 minute in 2021, estimated amount of data created on the internet in 1 minute is amazing. So we have an 500 hours of content uploaded in 60 seconds in 1 minute in 2021. 5,000 downloads were on the TikTok, 69 million messages were sent in a 60 seconds. These are the some of the areas where the internet is creating the what you can say, it's amazing. So internet is touching the every field and domain. It has not spared the manufacturing also. That is our next discussion, target of our discussion. So here the new business model, like buying the goods online, learning on the online, as we are teaching and we are learning on the online, there are some softwares available that we are making use of it. And we are experiencing the challenges also, like as I experienced in the start of the lecture. So we haven't listening to the music, watching the film and playing the online. I'm just keeping this video. I want to play it, but due to some time, I'll just keeping it. Learning on online means there are some augmented reality and virtual reality packages are available, and that with that packages you can create an immersive and virtual environment to your students, where you can show them in a 3D view virtual world what you have to learn, or in what way you can have an access to that particular your topic. So this is what I want to show in this. And there are certain other technologies are coming up, so that this drone taxis are there, artificial intelligence, virtual reality, 3D printing, that is 4D printing is also coming up in this fourth industrial revolution. Autonomously driven cars, Internet of Things, quantum computing, metadata analytics, digital currencies and blockchain, that is the Bitcoin and other digital currencies are coming up. Then bioengineering there, and the metaverse is the latest discussion topic. This metaverse, basically, I'll take the 2 minutes on this metaverse because this is very, very important, and this may create the magic in the world of performing artists. This metaverse is a public virtual world, and you can access this through internet. This virtual world experience or it simulates the human emotions and gesture, and you can create a virtual 3D world. That world is interactive, immersive, and collaborative as well. And this is not the one technology, this is the group of technologies combined together, and it performs this virtual world. You can perform actually in the virtual world. That is augmented and virtual reality is used in mixture with artificial intelligence, and we also use the blockchain to create the scalable and correct virtual world. So as I said earlier, this industrial revolution is creating the magic in every field, be it medical, be it agricultural, be it your banking, home, smart home, or your infrastructure or transportation. In every field, this fourth industrial revolution or the use of advanced technologies, you can see it. I'll take one example of here. In a medical and healthcare field, we have a medical diagnostics, X-rays, and a lot of X-rays need to be scanned and need a specialist radiologist for that. And then that specialist doctor or some special radiologist gives you this particular diagnosis, but with the help of some artificial intelligent algorithms or machine learning algorithms help us to diagnose and as correctly as your specialist, human specialist. So personalized medicine is the another example. Remotely controlled robo doctors, then 3D printed human parts, synthetic parts are the one example where the fourth industrial revolution is taking shape. Like that, there are some other examples are there which are making this our experience great. Smart home, connected workmen, collaborative robots. Then in case of governance, we have a digital stack over here. Then in case of smart infrastructure, we have smart city, smart surveillance, smart grid, smart parking. Everything is smart, coming as smart. So what smart is that we see in a latter part of my discussion. And drone taxis, ride sharing, that is a shared mobility. So these are there in every field. But what about manufacturing? In manufacturing, there are changes happening, and the changes which has happened or which are happening at production floor or at the manufacturing, that is referred to as Industry 4.0. And the changes which are happened or which are happening at a greater aspect or greater domain, these are called fourth industrial revolution. This what is the contribution is. So basically, what fourth industrial revolution or industry 4.0, I'll focus more on industry 4.0 from this point of time. This industry 4.0 focuses on higher level of automation. Then we are talking about the connection between the elements, be it a man, machine, material, or processes, procedures, anything need to be connected, integrated, and the systems need to be integrated. That may be a toolings, that may be any equipment, that may be any human. That system integration need to be there with use of Internet of Things, cyber physical systems, big data analytics, cloud computing. So these are the technologies are combined together and which are leading this industry 4.0. If some manufacturer, organization, or original equipment manufacturer want to implement this industry 4.0, or if as a teacher, I want to teach this particular topic, then what needs to be done for this industry 4.0 that has to be come upon. I mean, that needs to be discussed first. So what requirements of industry 4.0 are very important. So first and foremost, requirement of industry 4.0 is that you should have, as a manufacturer or as a entrepreneur, you should offer a smart product to the customer. That is the requirement of current industry or current market. So what are the different products available? These are the products available and we have used from the last 20-30 years. And we have seen the changes in this product, and these changes have happened tremendously. Meaning of this is that if you look back 20-30 years and if you see your workbench, work desk, the lot of instruments or the products have disappeared and only smartphone has come up. So this has happened in the last 10-15 years. So if you see this product, each product has embedded with some kind of a sensor, some kind of actuators, some kind of intelligence, I mean to say. So this product can sense its location, or the owner of this product can sense its location, trace it from remote location. So these products are embedded with some kind of a microelectronics so that the person can trace it, track it, and product itself analyzes its performance up to that level, and that leads to the product innovation. So there are certain other products are available and which are invented in the last 2-3 years, is that Philips lighting system is developed, where the Philips has developed this autonomous, connected and smart product, which can be controlled with remotely with your app, mobile app, and you can control or program this bulb in a such a way that if any intruder detected, then it can be give you the blink. It can send these signals, or you can switch on and switch off this this bulb from any location. So that can be possible. Here in the third example, here the Ralph Lauren has developed a T-shirt. This is, listen carefully. This is very important innovation in the fourth industrial revolution, is that the product is the T-shirt, and the T-shirt is having an sensors inbuilt in the T-shirts. So the T-shirt can be streamed or designed to stream the data of a particular person who has weared this T-shirt, and that basically it is for those who are working out, this gyms or the runner, they can use it. And the T-shirt, this T-shirt streams the distance covered by that person, calories burned, the movement intensity, heart rate, so on and so forth over the devices, so that a person can analyze its parameters and improve upon that. Similarly, this racket is there, which is inbuilt with the intelligence, so that tennis player can use this racket for analyzing his performance, be it you can ball speed, spin, or impact location, so that the user can improve upon his performance, or the company can use this product to innovate further. This is another product which is connected and smart product, Automate. I'm not the marketing person of this company, but I thought this should be worth to discuss with you. It's in a low cost, as low as 4,000 rupees, and has a Qualcomm chipset with a speed of 1 to 100. This product is IoT enabled, communication technology is there, Bluetooth. It has any humidity and temperature sensors, and you can switch on, you can control, basically control the this product from any location. So for developing this smart product, what needs to be done? We need the sensors, we need the actuators, we need the communication technology devices, communication technologies. So basically, for developing the any industry 4.0 vision in the company, you should have a smart system to be put in place. What is mean by the smart system is that earlier what we have any mechanics put in place. There is no any electronic component in this part. There is no any mechanical, there is no any electronic component placed in this system. This is called general frame, or it's a mechanical part, only mechanical part. Then we come up with the introduction of the mechatronics. Again, we made some developments, and we have this adaptive controller. So adaptive controller is that where he can take the decisions and give some input to the sensor or actuator, and it controls. If you inbuild this system with some kind of a communication technology, maybe it Wi-Fi, Bluetooth, or any wireless communication to the other devices, then becomes the cyber physical system. So I'll discuss the cyber physical system in the next slide. And what is the use of this? This helps us to monitor the condition of this product. It helps us to monitor or diagnose and control this particular product. And this helps us to track and trace this product from any remote location.
So these are the advantages of the cyber physical systems, and with help of the cyber physical systems, with some advanced emerging technologies, we can build a smart city, smart factory, smart plant, smart grid, smart products, smart logistics, and smart home. So this is the basic principle or component which leads to the fourth industrial revolution. So as I want to discuss the cyber physical system, and the cyber physical system in layman language is that we have a plant. This is the plant, and this plant has a n number of components, machines, material. There are some FIFO racks, there are some washing machines, there are some press machines, there are some logistic material is available over here. And on the machines, there may be a n number of components. And one of the component is this cylinder. Those who are from the mechanical or mechatronics branch, they know this cylinder. It works on some either on the pneumatics or hydraulics. So basically it is an actuator, and if this actuator embed with some kind of a microelectronics chips, and if you put the sensor on this actuator, so that it can sense its pressure, it can sense its movement, it can sense something, whatever you want to sense it. That smart sensor can sense the parameters, and if you then this system becomes, with sensors and actuator, this system becomes the smart one. Then if you put some communication devices or communication network system, maybe LAN, maybe WAN, Wi-Fi, Bluetooth, or internet, any internet communication technique, and they send the signal to the location wherever you want to send, then that becomes the digital twin. What is digital twin? The digital twin is a virtual copy of any physical system. So we can have an remotely monitored system. So the requirement of Industry 4.0 is to develop a digital twin concept in their factory floor or in their organization. That physical object may not be only this component, but it could be a raw material, shipping containers, there may be a plant toolings, or whatever the work in process flowing down the assembly line. It may be a process, it may be a human. So everybody should have a virtual copy of that physical object. Even we have a virtual copy of ourselves. I have a WhatsApp account, I have a Facebook account, I have a Twitter account. So I have a virtual copy of mine. My characteristics can be reflected with that virtual copy. So in the fourth industrial revolution, basically in Industry 4.0, the cyber physical systems, with these physical systems, with machine learning algorithms, we can automate these systems. So this part, or this is the pillar of one of the pillar of fourth industrial revolution. Another pillar in the fourth industrial revolution is Internet of Things. When you connect all these objects, all these machines, human, your toolings, material, with some kind of internet, and it connects with the cloud server, then you can have an access to the data. You can give the command to the cloud through the cloud from remotely. You can access the data, you can analyze the data. Now, when we have a different elements, when we have a different equipments connected with some stores, this cloud store, these are continuously sends the data. So the lot of data from multiple sources getting generated, and that needs to be stored somewhere, and we need to generate the value out of this data. Now this data has then three characteristics. One is the volume, variety, and velocity. With a tremendous velocity, with the variety and volume, we are receiving the data. And we need to create another fourth characteristics out of this data is value. So we have a different pattern recognizing softwares and algorithms from which you can gain the insight into this data, so that we can improve upon the business performance. we can improve or innovate our products. We can improve the productivity. Overall, economic growth can be possible with the use of these technologies. So for the driving these technologies and collecting the data and communicating with the different elements of the factory or organizations, we need a 5th generation technology standard for broadband cellular network. This 5G is 500% faster than 4G LTE network, and it is now currently launched in the America, US. According to the I'm from the automobile branch, so I'll give the one example of connected cars, and the 5G enabled connected cars are coming up. So by 2025, 1 in 4 car will be 5G compatible. Currently, we have a 90% of total connected cars have a 4G connectivity. So in the 2021 only, automotive industry saw the first global deployment of 5G enabled car, which was launched by the BMW iX model. And as we as we are moving with the electric vehicles, this 5G network will make a greater advancements in case of advanced safety and security in the connected cars. So the 5G will impact the industry, and it will help to develop the autonomous logistics. It will help to develop the real-time data analytics, and we can have a different autonomous machines to our disposal. So I discussed about the smart products, smart systems, cyber physical system, Internet of Things, and Internet of Services, and big data, and this 5G technology. It will help us to take the value out of this, and we can improve upon the different ROIs and other technology pillars for Industry 4.0 are these identifiers like barcode, RFIDs, RTLS. Then we have a cloud and edge computing. Edge computing is another field where scientists are working very heavily. Then we have a collaborative robots, then augmented reality, virtual reality, then autonomously guided vehicles. Then cyber security is another issue that needs to be taken care of. Cybersecurity technology needs to be put in place, the encryption kind of a thing. Blockchain is the another important technology that is being developing at the developing stage of the this. Then these are the different pillars of Industry 4.0, and as a company, as a manufacturer or manufacturing organizations, we have to select the whatever required technologies as per your vision needs to be decided. So earlier what was happening, we have a different information systems. We can collect the data, we have an information mechanism through which you can have you build the different software systems. Then we have different embedded systems. We have different systems where you can have this automation level, but they are isolated. Then some mobile applications were also there. So we were doing the optimizations at different pockets of the industry, different pockets of the organizations. But we need an ecosystem where you can use all these IS driven and ES driven and mobile systems to create the value out of it, and new business models, which are revenue generated business models, are required. So the normal innovations, which are competitive advantages, can be considered as your evolution, and the revolution maybe we can call it as that may enables you to generate a new market or to generate a new revenue. So Industry 4.0 is basically a smart ecosystem for the production. So the core idea behind the Industry 4.0 is this. So this is the traditional way of conducting the manufacturing, or where in this we have a different manpower put in place in that different cells, assembly line, and the the material or inventory is lying here and it has piled up. There is one way only communication is possible in this traditional way. So though these cells are optimized, but they are operating in silos. So there is no any two-way communication between the your supplier or network of supplier or the customer base. So this has to be replaced with this kind of a thing, where you have to be replaced with the manpower is going to be replaced with some kind of a machine or collaborative working may be there. Only 1 or 2 person may control the whole factory. Each product which is the smart enough so that that product itself can analyze its location. Product itself can tell that machine that these 4 operations need to be performed on that product, and what are the different activities has been carried out on that product itself told by the that smart product. And there is a two-way communication between this network of suppliers or logistic part with your inventories and this assembly section, and you can have an interactive communication with the customers too. So this basically the supplier can come to know at what time he has to deliver the product to the particular line, or the logistics department can decide based upon the inventory and based upon this this visibility on this at what point of time they need to deliver the product. So this is a fully integrated data flow, product flow, and that is not within the plants. These are going across the plant. These are crossing the borders. So there is very thin line between the network of the plants. So there has a machine-to-machine communication, machine-to-human communication, and it enables the customization, and it provides the mass customization. We are moving from the mass production to the mass customization in the industry 4.0. So basically we are creating the network of smart factories which are self-organized, which provides you the self-learning, self-optimized, autonomously driven, which takes the decision at decentralized level, and real-time data exchange and monitoring is possible, with which you can basically it requires the pillars, the technologies like CPS, IoT, iOS, and other internet related technologies. So here the massive integration of man, machine, material, product, systems, tools, and all other information processes or other part. So this is the core idea behind the industry 4. related or oriented organization. So for designing the industry 4, you should have to keep in mind these 6 design principles. If any organizations want to envision this industry 4.0, they need to be taken care of these 6 design principles. The first one is the interoperability. Interoperability is nothing but it's a networking and facilitating the communication between the different physical and this virtual system. It may be a human, or it may be a network of factories, or it may be a network of suppliers. Okay, so this communication is required. I'll elaborate this point. There are different machines are available. If any manufacturing is there, he has an n number of machines. Some of the machines might have 20-30-year-old, and some are new. So the communication platforms of the controllers are 23-year-olds, 20-30 years old, which are legacy product. And the current one may be having a new standards, communication standards, and communication devices. So here comes the a barrier to connect these 2 machines together. So they need a bridging devices to connect the older machines and the newer machines. So the interoperability is very, very important. Another part in this design principle is the virtualization. Virtualization is just like a digital twin. The decentralization means the factory needs to be capable enough to make the decision at a point of source only, origin only. So real-time capability, so that we can analyze the data, improve the insight into the processes, procedures, or machine. That is the real-time capability. Service orientation is another important point, and there are so many the offerings are available in the service orientation. This one, that internet of services. So you can provide the different services over the internet, like you can provide the platform as a service, you can provide your software as a service, you can provide machine as a service, you can provide the drone as a service. So there are n number of services you can provide over the internet, and the modularity is just kind of a flexibility. So if anything happens with some part of your factory, then it should not affect the entire factory. So these 6 design principles are very, very important to set up Industry 4 vision smart factory. Another important part in the Industry 4.0 smart factory is when we are moving from the digital world to the real world, the product goes through the different cycles, from the conceptualization of that product to the design of the product to the production planning, production engineering, production and service, and put in place and disposal. So whenever that product moves from this 1 to 5 stages or 6 stages, it goes with some kind of a software. And these softwares are there in the current industry organizations, but they are operating in silos. There is no any connection between this. So whatever the data is available at the plant floor from the sensors or actuator, it is only limited to the certain access. That is not transmitting to the MES, manufacturing execution systems. And from the manufacturing education system, it is not moving to the PLM software or BAMP software as customer relationship software. And we are not getting the optimal benefit out of these softwares. So these information flow related softwares has to be connected, and data needs to be transferred from these softwares so that the visibility can be improved upon. So the next part of my discussion is, this would be the network of smart factory, or we can call it as a factory 4.0. If you see this image carefully, it has all the features, it has all the principles of Industry 4.0. If you start with a supplier network, you have a cluster of network. Those are also compatible to the Industry 4.0 vision. They need to be work upon this concept, as most of the industry clients are working on the lean principle. Likewise, they have to be also compatible with the Industry 4 concept. So there are resources of the future, that alternative or non-conventional energy source. So we have to be think about this also. Then new customer demands are coming up. The volatile market is there. So mass customization is more. Earlier, what we used to do, we used to produce the product in a mass, that is the mass production. But we are now moving towards the mass personalization, mass customization. And we need to provide the client the facility to change their product characteristics or the product specification at a later stage of manufacturing. So these kind of facilities needs to be provided to the customers, and the customer needs to be taken care of in this Industry 4. Another part is that whatever the tooling or equipments you are using, that may be a 3D printing, 4D printing, or additive manufacturing, nanotechnology or some materials are also used. Then the robotic or cobotic systems are to be put in place, autonomous vehicles, then sensors, and we have an advanced manufacturing systems. This has to be put in place so that you can send the data, you can continuously monitor the data, and you can give the cloud computing facility. Of course, we have a cyber security issue that needs to be dealt with. and the big data can create the value out of your various processes or whatever the data coming out of from your plant. So this is a plant of the future, and there is a cluster of plants. So from doing this, what we can achieve? So we can achieve the productivity, we can achieve the flexibility. Already we have discussed this point. We can achieve the highest level of quality, and with the speed, you can produce the component, you can market the component. That is the time required to launch the component product in the market. That is, apart from this productivity, flexibility, quality, and speed, you can improve upon the safety of worker. Work-life balance can be improved. You can have an improved training and the collaboration among the human beings and machines. By using this material, new kind of a material, if energy efficient material, you can improve upon the environment. Another is that this you can have an improved or increased innovative capability also. So if you go through the productivity improvement, this is, you can generate just like a smart factory or a dark factory where the higher level of automation is there, which reduces the production time, enables the better asset utilization. Inventory management can be taken care of, and the predictive maintenance can be achieved, which avoids basically the machine failure on the factory floor. So my friend is there in the XKF Pune plant, and he was telling me that their Sweden plant is running on the 2 to 3 workers. So in the 2 to 3 workers, they are producing as much as what the Pune plant is producing. So this is the kind of a light out factories or dark out factories work 24/7 and 365 days without manual intervention of human. So this kind of a vision has to be there to achieve the industry 4.0 here. So we can save lots of on the you can save lots of on this this predictive maintenance. So currently we have a diagnostic and descriptive analysis, and you need to move on to this. Our organizations need to focus on the machine learning, and we need to focus on the predictive kind of analysis from the data, so that you can improve the productivity, and downtime can be reduced with this predictive and prescriptive. The prescriptive is the general recommendation provided from the algorithms, and you can work upon that to create the value. Next part is, as I discussed, there should be a two-way communication between the manufacturer and the customer. You need to fulfill the customer's demand. As a organizations, customers' demands needs to be fulfilled from the participation of the customer, from the product specification to the design, to the configuration, then ordering, planning, production, and logistics. Up to that certain level, you should have as an organization should have an ability to provide it. The quality is another parameter. In the quality, you can put several sensors, video cameras on the shop floor, and these cameras regularly monitors the production. It checks the quality of the product, and it quickly intervene whenever there are cases of errors. We have a concept of Six Sigma. It is still far away in the third industrial revolution, but we can achieve on this in the next few years. So the next point is a speed with which we can launch the product in the market with digital design concept, virtual modeling concept, and the manufacturing processes and the data-driven systems. So you can launch the product in a shorter duration of time with some kind of these digital techniques. You can simultaneously design the product as well as simultaneously you can build the manufacturing facility, and simultaneously you can build the supply chains. So to achieve this, what is required? We require the this response to this all these softwares, all these the technologies, and through this these three design features of industry 4.0 need to be taken care of. Here the end-to-end design digital integration is required from the all the engineering to across the entire value chain, and vertical integration is talking about the network of manufacturing system, integration of information technology from the shop floor level to the higher level, and horizontal integration is talking about integration of your suppliers, all the suppliers with your IT system, means organization's IT system, and customers also can connect with your IT system, the information transfer system. Means from sensor level to the enterprise level has to be connected, integrated, and communication need to be done. So the another part is this is the explanation, technical explanation for this these three features. I'll just quickly skip this because we are running out of time, and I'm coming on the last part of my discussion is by doing this, what are the opportunities for India? Or this concept, this industry 4.0 is becoming the buzzword, and everywhere it is being discussed now. I'm closely following this topic with industry persons and academicians also. And what are the opportunities available for India in the context what we have currently now? So, as I discussed earlier, this requires a lot of automation and other skills. So here, one important point as far as India is concerned, we have an youngest population in the world. In the year 2020, age dependency ratio was 49, and the world's age dependency ratio was 54 or 55 somewhere around. So we have an youngest population, working population. Another important point is manufacturing sector's GDP is currently 13.5. In the last 2 years, it was 16, and it is expected that it will reach 25% by 2025. And if you take an example of one sector, automotive sector, it is expected to be grow, and it will be at third largest market, automotive market by volume in the world by 2026. Currently, we are number one in the two-wheeler manufacturing, three-wheeler manufacturing, and tractor manufacturing. And we are second in the bus manufacturing and fourth in the passenger vehicle manufacturing. This data is of 2021. Another important point as far as India is concerned, the penetration of mobile users, internet users, and social media users. That is, so we have a large number of mobile users. In January 2021, this data was in 2020-2021 between this. So 110 crore people were using this mobile phones. Internet users were 62.4. Means we have a network of mobile users, mobile devices. So that is the encouraging thing as far as India is concerned. So we have a lot of mobile connections in India. The another part is we have a strong domestic market, and abundant opportunities are available. Then still we as a manufacturing sector has still enormous potential is there to embark on the industry 4.0 at an early stage. But the care needs to be taken that every nation or organizations need to devise indigenous or tailored road to Industry 4. Because this concept is not as that the philosophies that have generated in the past, like TPS or like lean production. This is entirely different, and we cannot replicate whatever these Western organizations, Western partners are doing it. We need to develop as a nation, we need to develop vision for this, and we are doing it right now with different policies. There is no one size fits all strategy for future innovations like Industry 4. And we should also, as organizations or different manufacturing sector, need to assess their goal for the Industry 4. They need to assess the current situation or status quo, and based upon that, they can decide the future action plan for Industry 4. So it is a very complex thing to achieve. And another 2-3 important points are there. The potential challenges to the our country is that they are different from the developed economies, and a level of industrialization is the another point where we are lagging. Then availability of productive population is the another part. As far as the organization is concerned, the base and starting point is different. Still, we are confronting with the challenge of building the basic prerequisite. We are not having that much of broadband connectivity in the remote locations, in the rural part of the our area. Then whenever there are some higher end technologies are there, you should not copy that. Instead, whatever amount of or whatever the stages of these technologies are required, that needs to be adopted, and that requires the vision mission. There are some challenges are there that needs to be taken care of. Like at government level, there are different challenges. At industry level, there are different challenges. New technologies are coming up. The training and the certification courses need to be set up. We need to reorganize our curriculum. We need to develop some new training courses. We need to inculcate the positive attitude and mindset. And as far as the policies is concerned, we need cyber security, data protection, and we need Industry 4.0 framework to set up. And these, along with this, there are the big data. This is the technology that needs so many skilled practitioners, data analytic, then data scientist. We need a data engineers. So we need to have an address these challenges. So for this, we should, as your government organizations or as a technical education institute, we need to work with the higher learning institutes, with the government, and also we need to work with the industries to develop this Industry 4 concept. For that, we need to develop skills. We need to reskill, we need to upskill, and we need to revise some syllabus or curriculum. From the policy point of view, incentives, data security laws, labor laws are need to be framed. Then culture need to be developed. Change process is the one thing. And for this, we need to influence the curriculum. We need to have a different approach for teaching and learning. We need to develop the skills and competencies. And these are some of the skills that need to be, these skills are a need of a fourth industrial revolution. So what government is doing for this, or what organizations are doing for this, is government has developed different policies, coming up with some initiatives like Make in India, Digital India, Skill India, Smart City. Cyber Physical System Innovation Hub has set up. Center of Excellence for IoT has been set up. Task Force on Artificial Intelligence was set up in the before the 2018, and recommendation were also given by that task force how we can implement the artificial intelligence in the context of India. And Professor Kamakoti was the chairman of this task force, and now he's the director of the IIT Madras. We have a digital stack, Aadhaar Covin. We have a national manufacturing policy, and all these are in line with the Industry 4 vision. There are some key initiatives taken by the Indian organizations. Some of them are from the technical institutes. Indian Institute of Science in Bangalore has developed the first indigenous smart factory, which is funded by the Boeing company. Bosch has implemented this concept in India in their plants across the India, 15 centers. GE has developed and invested around $20 million in multimodal factory in India. It is in Chakan. CMTI has developed this smart manufacturing and industry 4.0 factory. Center for Intelligence, Center for Industry 4.0 lab is developed in Pune, which provides the training and required assistance to the small manufacturing enterprises. So this is what different organizations and government are doing as far as this Industry 4.0 is concerned. And the concluding comment is here, it is no surprise that this inception of industrial revolution remains an epicenter for innovation and growth in digital economy. Smart factories, advancement in supply chain, and transformation of your traditional relationship with the supplier and customer, it will definitely change. The companies that are successful in capturing and analyzing the data and information can unlock this exponential growth opportunities, and they can accelerate along the innovation curve. However, the journey isn't without the challenges, and those who are not on this journey will be left out in coming decade. Thank you. Thank you for your time. Thank you, sir.
Thank you very much, sir. Dr. Santosh Chaudhary from Government Polytechnic here.
Just a minute, sir.
Very nice and informative lecture delivered by Wagire sir. So before going to conclude this session, if participants are having some question, they can raise their hand and they can ask. Very nice and informative lecture delivered by Wagire sir. We start with journey from very basic different industrial revolution. Very nice examples are given, and after that how this industrial revolution come to end with Industry 4.0, what are the products and what are the different features that are covered under this Industry 4.0, how we can differentiate evolution versus revolution, what are the design principle behind this, and what are the features of Industry 4.0 has elaborated by Dr. Wagire sir in this lecture. Thank you very much, sir. Again, the challenges and how we can improve with help of this Industry 4.0 to improve our Indian scenario, that also very well delivered by Wagire sir. Thank you very much, sir. Thank you on behalf of Mechanical Engineering Department, Government Polytechnic Nanded. Thank you. Thank you for this nice lecture.
Thank you, sir. Thank you.
Participants, if somebody wants to give some feedback, they are welcome. Yes, Umesh, Yuvraj sir, please unmute your mic.
Hello, good afternoon, sir.
Yes, good afternoon.
Wagire, sir, thank you very much. It was very nice presentation related with the Industry 4.0. सर मला फक्त एवढं विचारायचं होतं की हे जे काही इंडस्ट्री 4.0 चे जे काही कन्सेप्ट वगैरे आहेत किंवा इम्प्लिमेंटेशन स्ट्रॅटर्जी आहे तर आपल्या इंडियन कंटेक्स्ट मध्ये याचा काही स्पेसिफिक असा स्टडी वगैरे झालेला आहे का कुठे म्हणजे कारण की आपलं डायव्हर्सिटी किंवा पॉप्युलेशन आपली इंडियाची वगैरे जी आहे तर इथं हाऊ मच विल बी सक्सेसफुल असा काही स्टडी वगैरे काही स्पेसिफिक झालेला आहे का?
Correct. Myself had studied this particular part, how much we are, आपण किती पाण्यात आहे as a industry, हे मी पाहिलेलं आहे. And because this concept is merely 8 to 10 years old, and we are developing on that. Like Industry 4, there are other concepts also, which are similar on the ways of this Industry 4, like factories of future, advanced manufacturing system, smart manufacturing, factories of the future, internet, industrial internet of things. All these things are the concept are available from the last 10 years and having the same vision as that of Industry 4. But the name given by the German manufacturing industry or German government for Industry 4. Otherwise, the concept is same in all the respect. And as far as in context of India, we are still not up to the mark to the Industry 3.0. We are still confronting with the challenges of basic infrastructure, maybe at equipment level, automation level, and other internet and other related technologies. So there are some studies are coming up which are identifying the status and readiness of Indian organizations. Some of the studies are already published, and some are in the pipeline. But the most of the studies are focused around the technologies like Internet of Things, blockchain, and other related technologies, but not in a concise or in an aggregated way.
सर याला लागून एक असा छोटासा अजून एक प्रश्न असा होता की तुमच्या दुसऱ्या स्लाइड मध्ये आपण जे काही बघितलं इंडस्ट्रियल रिव्होल्यूशन जे झाले फर्स्ट सेकंड थर्ड म्हणजे वाफेच्या इंजिन पासून पुढे आपण आलो तर हळूहळू आपला ह्या दोन फेजेस मधला वेळ कमी होताना दिसतो म्हणजे ड्युरेशन.
That's the point. That's what I mentioned. The exchange of the acceleration is very fast. We are moving. It took 100 years to move from the industrial revolution 1 to 2, 2 to 3, but third revolution and fourth revolution, it took only 20 to 30 years. So the change is happening very fast. That's what my first 2-3 slides was.
Thank you very much, sir. Thank you, sir.
Thank you, Mr. Thank you.
Thank you, sir.
Thank you, sir. Thank you.
Is there anybody who need to ask, or shall I conclude this? Okay, sir. Thank you very much. From Government Polytechnic Nanded.
Thank you.
भेटूया सर आपण एकदा. छान झालं तुमचं लेक्चर.
बिलकुल सर. Thank you, sir. Thank you.
Okay, thank you, sir. Thank you.
Yes, sir. Thank you. Thank you. Please convey my regards to Raju, sir. He is in there. Please
Already.
convey my regards
Yes, sir. Definitely, sir.
Your honorable principal.
Yes, sir.
Thank you so much for inviting me here. It was a great experience. Thank you. Thank you.
वागिरे सरांचा नंबर आपण नोट करून घेतलाच असेल. पॉवर पॉइंट प्रेझेंटेशन आपल्याला शेअर ऍज अ या एफडीपीचा पॉवर पॉइंट प्रेझेंटेशन आपल्याला शेअर केलं जाईल. इफ यू हॅव एनी doubt, then you can ask with kind permission from Wagire sir. तुम्ही त्यांना मेल करू शकता. Next session, before going to start with the next session, attendance link is on your group, and you can give the attendance. So with this, I will conclude this session. Thank you very much once again, sir. Thank you, sir.
Thank you.
Participant can leave meeting now. Thank you, sir. Participants, attendance लिंक शेअर केलेली आहे. प्लीज अटेंडन्स वेळेवर द्यायचंय. ती लिंक काही वेळापूर्वीच आपल्याला इथे असेल.